Okay, this is a Statistics with R presentation, and this is an introduction to R for actuarial students. This corresponds to the CS1B curriculum that actuarial students will encounter over the course of their studies, and it comprises an introduction to R programming and fundamentals of statistical analysis. This is question 3, which concerns hypothesis testing with the t.test command. Okay, so a machine in a sweet factory fills bags of sweets to weigh 500 grams. The actual weight in the weight of the bags of sweets is known to follow a normal distribution. Okay, just to sort of get that out of the way. The sweet manufacturer believes that the machine is underfilling the sweet bags. So a sample of 10 sweet bags is taken and weighed as follows. Okay, so those are the 10 bags, and those are the weights corresponding to the 10 bags of sweets. Okay, you notice that some are well below 500, but some are close to 500, still below, and some are a bit above 500. Okay, now remember, this is just a sample size of 10. Okay, now this is an important point here, underfilling. So the mean should be at least 500. Okay, so that's an important thing going forward, that it's a one-tailed procedure. It's not a equal to or not equal to 500. It should be really greater than 500 at the very least. Otherwise, that's not underfilling. Okay. So we can create the data and input it into R using the following commands. Okay. So that's our data there. We don't really need to put in the bag numbers. Okay. So it's a single data set. So just create all the vector based of all the numbers, and we use the C command, which is to concatenate them or combine them into a single object called weight. So perform a suitable t-test to determine whether or not the sweet bags are consistently underfilled, stating the hypothesis and the level of significance used. Now typically you would use a hypothesis or significance level of 5%, so we'll just do that. Okay. We should also state the null hypothesis going forward, but actually when we come to the t-test we'll actually sort of see what we will be doing there, because that's part of the output. So the test has the null hypothesis that the sweet bag weight is equal to 500 grams, and the alternative hypothesis is that it is less than 500 grams. In fact, you can really restate it to sort of say it is at least equal to 500 grams or more. You can sort of slightly restate the null hypothesis that way. But the alternative hypothesis is very clear. This sort of encapsulates what the data might be telling us, that the average weight of the sweet bags might be less than 500 grams. And that should be sort of consistent. It should chime with what our impression is coming from the data. Okay. Just as a quick remark, we looked at the data set there, and we didn't really calculate the mean, but it's actually given there. It's 497.04. It seemed to be the case that more of them were under 500 than above 500. Okay. Now, so we name the sample that we're using. This is the data set, but in this case it's the sample of weights. Now, under the null hypothesis, we're interested in this value here, 500, both for the null hypothesis and the alternative hypothesis. So we have to specify the supposed true mean under the null hypothesis, 500. Okay. Now, this is a one-tailed test, so we actually have to specify it as such. And we actually specify that the alternative is that the true mean is less than 500. Okay, so this sets up a one-tailed test. Okay, and of course we use the command t-test. So this is the output. That's our test statistic there. Degrees of freedom. The p-value. Okay, and that's what we're going to use to interpret. This is a statement of the alternative hypothesis, okay, as it is up here. That's also useful to know, just in case it makes crystal clear what the alternative is, and the null hypothesis is that the true mean is not less than 500. That's the null hypothesis. We can use this to sort of look at a confidence interval. Now, this may be the case that we get a minus infinity here. Don't really worry about that. What we're looking at is this, that this value is in excess of 500. So essentially 500 is in that range of values, and I know that minus infinity is a bit of a strange one there, but anyway, 500 is still in that range of values. That's our sample mean there. So we are running a one-sided t-test because we're so I sort of mentioned that before. Now, essentially, this is what we're looking at here, the p-value. That's the key thing there. Using this p-value at a 5% significance level, okay, that we fail to reject the null hypothesis that the sweet bag's weight is equal to or possibly greater than 500 grams. We fail to reject that null hypothesis. There's not enough evidence here. Okay, so we cannot reject the null hypothesis. The conclusion, since we cannot reject the null hypothesis that the mean sweet bag weight is 500 grams in favour of the alternative that the mean sweet bag weight is less than 500 grams, there is insufficient evidence to say that the sweet bags are underfilled. So what we would do there maybe is get more sweet bag and weigh more sweet bags and get a larger sample size. Remember, this is everything to do with the fact that we just have 10 sample items there, or 10 observations in our sample. That's it. We'll leave it there.